Our next class, I think this is ninth class for flight mechanics. So already we have taken few ideas about three types of conditions: minimum power condition, minimum drag condition, and minimum DYV condition. So we will deal little bit more in that. So see, you have to drink this equation the way I have done. You need a glass. In that glass you put either milk or you put water or anything else, and then you take a piece of paper. In that you write those three equations and the takeoff speed, landing speed, and for military and commercial. Then you put the paper in this water glass after cutting a lot of pieces, and then stir well and then drink. And after that try to write. If still you are not able to write the equation, then again you do the same. Do something else. Means this, I am trying to say the advantage of this equation. Like in last class we have deal one equation, we have done one question also. There we saw like how are we doing this. So we will see these condition in terms of drag. So when we were talking about minimum drag condition, then we saw that this graph we saw like this drag is here, this drag is here, and we understood that because of these two drags we are having total drag like this. And then we saw that okay, at this point your total drag is minimum, so this point is nothing but this point. So it means what, this line and this line, they are having equal coordinate here. So because of that you can get the physical feel, okay, both the drags are equal here. So minimum drag is the condition when both the drags are equal. So in same way there is something called minimum power condition. So what about minimum power condition? What will be equal when we are talking about minimum power condition? So when you will deal with minimum power condition, that time you will say slope, of course slope is zero. Of course slope is zero. So which slope you are talking? This graph, which slope you are talking? This graph is done between, in which two axis this graph is done? This graph is done between drag and velocity. So actually we don't have to bother about the slope, because dt by dv is not giving you any physical feel here. So why to bother about slope? So that's why we don't discuss about slope. We only discuss about the coordinate here in terms of minimum drag. Now condition is, if you are flying at minimum power condition, then what is drag situation that time? So for that there is a proper proof. With the proof we achieve a situation for the minimum power condition. If you are good in mathematics, then you can go ahead in this way. I will not do that. You have power formula. What is power? Already I have done this. Power is nothing but we are talking about the power required. So that is nothing but thrust required into velocity. Which velocity? The forward velocity. Okay, now here again this force is nothing but the drag, equal to the drag, because we are dealing with what kind of flight condition? Steady and level flight condition. So the drag formula, when you substitute here, even in the drag formula you get the velocity term, so and you get CD term also. So clearly you can see, if and one more thing, if I'll write here power required as in terms of half rho v square s CD, and if I write this velocity here as it is, then you can see here this square and this v gives you that power required is proportional to v cube. Okay, after that again you have situation. This CD is here, and if I will say what about your CL condition? So means I am trying to convert my entire equation in terms of CD and CL. Then I will check, I can clearly see after substituting velocity in terms of CL that your power required is actually proportional to CD. You can see directly here, but CL power 3 by 2. Now CD again I can break as CD naught plus KCL square, and then I'll be getting this much relation. So according to this relation I will go and judge power requirement condition. How to judge power requirement condition? I am trying to discuss minimum power condition. So from mathematics we have logic. Whenever you trying to approach minimum or maximum, what do? We differentiate, correct? So you have to differentiate a quantity with respect to another quantity. So by your basic need you will realize that the quantity what you are going to judge for the minimum, that is power required. But with respect to which quantity you are going to judge the power requirement? So your entire equation is remaining in terms of CL. So you have to bother about dP by dCl. So you will find out the equation of dP by dCl, and that equation you will put 0, and then finally you will be achieving that your A is equal to 1 by 3 dCl square. this is nothing but this guy, parasite drag. This guy will give you induced drag coefficient. I mean here. So from this you are achieving one idea. Your parasite drag will be equal to 1/3 times of induced drag. So if parasite drag and induced drag relation you have achieved, so see, in case of minimum drag condition, parasite drag was exactly equal to induced drag, exactly equal, because they got the same coordinate. But here your parasite drag is 1/3 of induced drag. Now, how will you understand this physically on the graph? So first thing, I will summarize again. See guys, in case of minimum drag condition, in this graph, you got one line like this, one line like this. Which line was induced drag line and which line was profile drag or parasite drag? Can anyone tick here? Very good. This was induced drag. Okay. So you can see here, in case of minimum drag condition, they both are exactly equal. So you can write your A is equal to completely BCL square, right? Because this entire thing is your CD naught and this entire thing is your CDI. But if you will talk about minimum power condition, then according to mathematics, it is coming that your parasite drag, or you can say your profile drag, that is, you can say this is equal to 1/3 times of induced drag. Okay, now you see, in the same diagram I will draw, so this will be going for induced drag and this will be going for parasite or this drag. So where is the location, where is the coordinate where your this drag, parasite drag, is 1/3 of induced drag? 1/3 of induced drag, of course this side, because this side parasite drag is more. Only this side parasite drag is less. Because you can see, when you will divide induced drag by 3, then you will be getting parasite drag. Means parasite drag is less. So where it is? Definitely this side. I am considering this as reference. So where is that? So you have to check the height. This height you have to compare with this height. Suppose, just imagine this height is 0.3 and just imagine this height is 0.1, like here. It means exactly this is the point where your power minimum condition is occurring. It means now go to the more physical field. What was this point? This point, actually keep in mind, drag versus velocity graph we are discussing. So this was the velocity when, as a pilot, when you will achieve this velocity, then you will your drag will be minimum. But as a pilot, if you are achieving this velocity, which is less than minimum drag velocity, guys, try to understand. When you will achieve this velocity, then there will be a velocity here and velocity here. You can see minimum power condition you can achieve when you are flying less than this velocity. What was this velocity? Minimum drag condition. I hope you are understanding what I am saying. Guys, tick here if you have understood. Very good. Today also I can see only 16 students are attending. Total we should be 34 including me. Okay, I will explain again. See, you have two types of situations. One situation is minimum drag situation and one situation is minimum power condition. Okay, in last class I have explained the physical meaning of these two. In today's class we are trying to understand what is the velocity when you will achieve minimum drag, the physical field, and you will achieve the minimum power. So that's what we saw on this graph. Here you have drag versus velocity graph. Sorry, this is drag. So this is your induced drag and this is your profile drag or parasite drag, you can say. So this is the velocity when both the drags are equal. So this velocity you will give a special name, that is minimum drag velocity. I mean, pilot is flying the aircraft at such velocity when pilot is experiencing minimum drag. I mean, aeroplane is experiencing minimum drag. Okay. So pilot wants to fly at a particular velocity when pilot has to experience minimum power. Minimum power means, if you will check out minimum power condition, then minimum power condition says when your induced drag is when your parasite drag is 1/3 of induced drag. So where it is? This is somewhere here. You can see this graph. This graph is for the parasite drag, and you can see, go ahead, this graph is for induced drag. Okay, so here you can see induced drag is larger and parasite drag is smaller. So just consider for an example, like this is the velocity where it is 1/3. I mean, this height is 3 and this height is 1. So if this is happening at this velocity, so I'm trying to say that minimum power condition velocity is the less velocity than minimum drag condition velocity. That's all. Now I'm going to give you more interesting fact. Let's see those facts. Clear hua? Clear? Everyone? Okay, very good. Now see, I will change the page and I have to explain something in detail. So what will you write here? You have to draw. Yes. You take notes like this. Minimum power and minimum drag velocities. So in that you will write like this. Drag versus velocity you draw, and then you draw induced drag, and then you draw like this. Okay, and in future if you are forgetting where is your which one is your induced drag, so always remember by trick, pi, simple. So write your p here, I here, then only it will be pi. So p for parasite or profile, and here I is induced drag. Then this is the velocity where your drag is minimum, and imagine this is the velocity where this drag and this drag. Suppose this is your dp and this is your di velocity. So just imagine, let dp is, actually I said wrong here, it should be p, it should be I, because this should be p, this should be I, because you can see. So this dp is equal to 1/3 of di. So at this condition, whatever is your velocity, that velocity is v minimum power. So I am trying to say that your minimum power velocity is actually less than minimum drag velocity. Based on this is the key point here, that's all. And this is the condition for minimum power. This is the condition for minimum drag. In future, when you will forget these conditions, how will you recall? For that, you have amazing trick. Amazing trick. I will tell you what is the trick. First, you copy down this. And how do I remember these things? Best trick. Done? Then I will teach you trick. One by three. Okay. Now I will change the page and see the trick here. First I will teach you trick, then I will give you physical feeling of minimum d by v condition. Okay, I am going back. Pratik, you are in class today? How is Bangalore going? It's good. You are liking Bangalore? How is the weather there? Always rainy. Okay. So you are very near now. So we'll meet. Okay. Chennai is very near. We will meet and one night we'll have class together. I mean, I'll be teaching them on online and you'll be sitting next to me on the same table. But in that, but then you have to pay extra fees. You have to pay total 50K now if you want one day live class. Okay. 1 lakh, very good. Okay, copy down. Done. Okay, now see, I will change the page. See, trick is, I have given you minimum drag condition, minimum power condition, and minimum d by v condition, right? So in these three conditions, I have given you CL formula. So if you recall, CL is equal to, I have given A by B, CL is equal to under root 3A by B, and CL is equal to under root A by 3B. So that's all, trick over. You do one thing. What we are going to compare? We are going to compare parasite drag with our induced drag. So what is induced drag? Induced drag is nothing but BCL. I mean BCL square. Parasite is nothing but A. Okay. So all the formulas you shuffle, square and do here and there in such a way that you can find A one side and remaining thing one side. So in minimum drag condition, you square this and then find out A value. So you can clearly see A is equal to BCL square. This is what I have taught you just now. In minimum drag condition, your parasite drag is equal to your induced drag. So this is your induced drag. In same way, you find out A value from this. Okay. So you can clearly see your BCL square by 1 by 3 is equal to your A. A is parasite drag. Parasite drag is 1 by 3 of induced drag. Very simple. Now you can easily judge our next topic. Next topic is we have to find out which velocity, I mean the velocity at which you are following minimum d by v condition is where is the location of that velocity? I mean on this diagram I have induced drag and I have this drag. A is CD naught. A is CD naught. Now see, this guy is your drag, this guy is your velocity. So just now we have identified one velocity here. This velocity was minimum drag velocity, and we have identified one velocity here. This was minimum power velocity. Now we have to check a velocity where you have minimum d by v condition. Janam, these formulas I have given in previous class. Minimum power formula is this. I am just trying to give you trick. In that trick, I am trying to say how will you shuffle and find out relations. So here you can clearly see your A value is nothing but 3 times of BCL square. It means when parasite drag is 3 times of BCL square, then only you are going to achieve the condition of minimum d by v. It means in the graph, where will be that velocity? Where? Can someone tick on my screen? In this graph, where will be that velocity location? In this graph, where will be the velocity location? Yes, somewhere there. Very good. So somewhere there, you can clearly see your A value. A is nothing but your dP, parasite drag. And here you have induced drag. So you can see induced drag height is only this much. But your A height is 3 times. So consider this height is 3 times. So this is the velocity where you have minimum d by v condition. Okay. So I will change the page because that's all. So you have to write a relation, and that relation is, I will write the relation here. Just a minute. The relation is V minimum power is less than V minimum drag is less than V dy b. Okay, that's all. This relation you can copy from the graph. I will change the page. Take down. Done. Okay, this is the last page. Now I will give you one interactive question, and then I will teach that topic. Question is, if you are new about this topic, then think. If you have done this topic in your classes properly, I mean in your colleges, then it will be very easy question for you. But if you are a new student for this topic, then it will be interesting question. Question is, do you think drag depends on weight? I will change the page. If you think drag depends on weight, tick here. If you think drag does not depend on weight, tick here. Depends. Does not depend. I have to teach this topic, just being interactive. So 4 students are thinking drag depends on weight. 5 students. 6. 7. Okay. See in this way. First I will make you confused by wrong logic. Then I will come to the right logic, so that I can shake your concept. Why do we have drag? Suppose you are designing aircraft like this. Suppose you are designing aircraft like this, and I am giving you the front view, a top view of the aircraft. Aircraft is going in this direction. Then whatever air will come, this air will face this much profile drag. Profile means how the aircraft look. What is the profile of aircraft? That is called profile drag. So profile drag is acting. Okay, one type of drag. Then again, if you have supersonic flow and subsonic flow, then because of that wave drag will come. Okay, transonic drag will come. Okay, you have lift induced drag. So these drags are coming. In this entire drag, where the weight is coming? Weight is not coming. Right? So how can we say weight depends? I mean drag depends on weight. So this is my doubtful interaction, so that you can think on this in confused way. Then I will clear this point. You reply my question. If you are experiencing that it depends on weight, you can reply. Unmute and you reply like, how do you think it depends? What link? What is the link here? Mass never change. Mass never change. Mass will never change, Saurabh. No. I am not bothering about that weight which is changing with fuel. I am not bothering about that weight which is changing with fuel. But there must be some relation. Then only you can say it depends. Tell Vedant. No, that's what by. No, that. You are saying weight formula is half rho v square CD. Huh? But see, drag, you are saying this drag, in this drag formula where the weight is coming? So I am not talking drag depends on velocity. I am talking, is there any way you can connect drag depends on weight? Suraj, you are saying density. Which density you are talking? ये कौन सा नया नियम आ गया कि लिफ्ट इज इक्वल टू ड्रैग? वेदांत, ओके 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 ये स्वरंजीत, व्हाट इज योर पॉइंट? Okay, no problem. No problem. No problem. No problem. No, no. We have to discuss about steady level flight right now. Steady and level both. So, see. No, Saurabh, I'm not talking about the angle. I'm not changing angle. In steady level flight, weight is here. Drag is this side. Then how can we say that? Okay, you guys are saying that drag depends on weight, but any strong logic is not coming that drag depends on weight. So in that, like Vedant, you have told that weight is related to lift. Then you want to say that okay, drag depends on weight. How can you justify this? Vedant, you have to elaborate a little bit more. Very good. This is a very key point here. Yes. Very good. This is the key point here. Actually, drag, you cannot see W direct relation. So, see, in the beginning itself, I told you that actually, you guys are correct. Drag depends on weight. But I want to make you to become enough confused. And if you're not confused, if you're not being confused, then no problem. See, how to think about this. Drag is nothing but the total drag. There are so many types of drags. In that, one drag is CDI. I mean DI, induced drag. Induced drag depends on lift and lift depends on weight. How much lift you will produce according to the weight. So now question is, what will be the mathematical relation between a drag and weight? So it is very easy. So you take the point. Take the heading as effect of variation of weight on drag and power. This is your heading. Effect of variation of weight on drag and power. So very easy. Your drag is proportional to V square and your V square is proportional to W. So from here, can you guess? So you can see direct relation. Drag is actually proportional to weight. It means if I am giving you two different weights in the same flight, suppose the flight is started from Chennai and it is going to Hyderabad with 100 passengers, and then in Hyderabad some passenger changed and something number changed. Suppose now it is carrying 200 passengers from Hyderabad to suppose Delhi. So 100 to 200 passengers. So weight changed. So in this flight, drag will be something else. In this flight, drag will be something else. So drag is actually directly proportional to weight. Okay. Now here you will develop a relation, equation 1. That is nothing but d1 by d2 is equal to w1 by w2. So copy down this. Now relation of power. So for that I will erase the top part. So there is direct relation again with power, because your power is nothing but it is actually directly equal to drag into velocity. And just now you saw power is proportional to this, drag is proportional to W, so I can write W, but velocity you can see here is square, so under root W. So you got the idea. Power is nothing but W power 3 by 2. W is weight. Yes, Sindhu, any doubt here? Sindhu, any doubt? Yes, Vedant. No, actually, when we talk about drag, it is total drag. In total drag, there are all the forms, right? So the total drag variation I am discussing, and no doubt that induced drag will vary in same way, because induced drag variation is there. That's why total drag variation is there. So now here, what equation we are getting? Second equation. What equation? P2 by P1, or you can say P1 by P2. P1 by P2 is equal to not under root W1 by W2 whole power 3 by 2. Now see, based on this, twisted questions will come. Direct questions will not come. Twisted means questions will come in terms of percentage. If 10% weight will change, then how much percent power will change? How much percent, like so. So if you are not good enough in percentage, then you should work out some basics of percentage. So basics of percentage, you can cover from anywhere, like just 3, 4, 5 questions. If you will solve on percentage, you will get the idea of percentage, how percentage works. Now we have very important comparison. That comparison is about piston engine versus jet engine. I will change the page. Very good comparison. Take down the heading. Piston engine. Here you will learn a lot of things. Engine. This is very favorite topic है मेरा. Yes, new topic. Under same chapter, radial flight, we have new topic. So, this is very interesting topic. Very interesting topic. What is the question? Radial engine on train aircraft on Cessna is the example of it. Yes. Piston engine means you have piston there. What kind of piston? Any engine in which vibration is happening. What kind of vibration? I mean this vibration I'm talking, where you have piston cylinder arrangement. Okay, see, if you want to understand piston engine, you just look at this part. Imagine I am keeping one piston like this, and here you have a rod. All the combustion, IC combustion, like internal combustion, you know, right? We have two types of combustion. So in this internal combustion, everything is happening. Because of that, this piston is going up and down, up and down, up and down, up and down. So this vibration up and down, or you can say cycle, I can convert into rotation. I can connect this some crankshaft mechanism. I can connect into rotation. So I can put one piston, I can put one more 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 piston, and all will rotate the shaft, and I will arrange their mechanism in such a way that one time this guy will push, one time this guy will push, one time this guy will push, so that anyone will not counter other. So continuously rotation I'll be getting. So this is what about the radial geometry of the arrangement. Okay. Just because I got interest, that's why I have explained. So now see, piston engine versus jet engine. Especially we will be discussing which engine is performing better at low altitude, which engine is performing better at high altitude, and what is the main cause. Okay, why piston engines cannot fly with high speed, why they can't fly at high altitude, what are the main regions, and if they are putting any 4 options in GATE exam, like because which of the following is not the correct region for piston engine to fly at high altitude. So you should have the clear concept, okay? And anyway, this is the fundamental course. This is our core: propulsion, structure, aerodynamics, stability. So we should be very good in this. So see now, draw one line. This side we will talk about piston engine, and piston engine you can also put as propeller, so that it should be clear, piston or propeller. Sometimes you can say piston driven engine, propeller driven aircraft, both are same. And here you write your jet engine. Okay, students who have done propulsion with me in previous classes, you tell me what is the cycle used in jet engine? Very good, Brayton cycle. Now see, we have two types of power. In last class we have discussed available power and required power. So see, in case of piston engine works on the power, thrust engine works on the jet engine works on the thrust. So two things you should understand. If you draw power available versus velocity curve, and if you draw thrust available versus velocity curve for piston engine, then power available is almost constant with the velocity, but thrust available decreases with the velocity. And I have logic why it is happening. I will explain the logic. In same way, when you talk about jet engine, then there also you have power available and thrust available. Power available and thrust available. So power available increases with velocity and thrust available is constant with the velocity. So what is key point here? You should keep all the four variations in your mind. Now see, if see here also available. We have not discussed about requirement. I mean the power required, or you can say thrust required. So I am going to talk only about power required. So when you talk about power required, so in both the cases, either in case of piston engine or in case of jet engine, your power required is having this kind of graph. Like in this case also, power required, if you talk, and here it will be having this kind of graph. And here also if you talk about power required, you will be having this kind of graph. Power required is almost same. Now because power required depends on outer phenomena, right? It is not the engine phenomena. Try to understand what I'm saying. Power required is because of drag and all, right? If you don't have drag, you no need of power. Okay, because you have drag, that's why you need thrust and power and blah blah things to overcome them. Okay, but this availability is the engine phenomena. Like what kind of engine you are using? Okay, you are using General Electric, you are using Rolls Royce. Like these are the companies, and in future you will be getting jobs in these companies. ISRO, DRDO, of course. Now see, here based on this, at what altitude power available is sufficient, at what altitude thrust available is sufficient. According to that we decide which engine is good for what kind of altitude. And while completing this topic, we will introduce service ceiling and absolute ceiling. So let's understand the complete, very good discussion about these things. I will change the page. Okay, these two graphs are same. Okay, so you just whatever drawing here, same draw here. I will change the page. See, there is some theory which explains why power available is constant. Power available is constant, and here your power available is increasing. So of course this is propeller engine, or you can say piston engine, and here you have jet engine. So understand this logic. I will send you the PDF. So just first understand the logic. See, piston engine is power producing device, and because of that, at constant altitude, your maximum power available from any given engine is approximately constant, and it is purely depending on the velocity. What I'm trying to say, power is nothing but your drag into velocity, and if you are not changing your altitude, then drag will not change because density will not change. So your power is directly velocity. So you can see a straight line. What about this explanation? But jet engine is thrust producing device. So try to understand. Power is equal to thrust into velocity. So If you are talking about power available, this power available increases. Why it is increasing? Any guesses? Any guesses? Any guesses? Because your thrust your thrust available is constant. Thrust available is constant in case of jet engine. So power is directly proportional to velocity. So you got x proportional y, that's why it is increasing. Okay, now we'll go in detail so that you can get some more idea. If you think in this way, power available is definitely changing linearly with forward speed, and because it is changing, that's why we don't consider power available for the jet engine for the reference purpose. That's why we consider thrust available for the jet engine. And just opposite thing, here your thrust available is decreasing because it is propeller engine. And why thrust available is decreasing? Main problem is when you will go up on the altitude, you don't have enough density. You don't have enough density, so your thrust available depends on density. Okay, now see overall how much you have to take from this in mind. You have to consider only whenever there is a question about power available, quickly it should come in your mind. Power available is used for propeller engine and it is constant with velocity, and thrust available is used for jet engine, it is again constant with velocity, and thrust available decreases for propeller. Power available increases for jet. Now see, if this phenomena you understand clearly, then we will discuss power available variation for both the engines with altitude. So I am changing the page. Take down fresh topic as effect of increase in altitude on power available. Why I am doing this? Because in future this topic will connect with service ceiling. So see, for this actually in propulsion we don't discuss the variation of power. In propulsion we discuss how to find power. Here we are not going to find power. In flight mechanics, power and all we don't find because of the engine parameters like efficiency and blah blah things, pressure ratio, we don't find. But here we discuss the variation of power according to available density and blah blah things. So you draw power available versus velocity at mean sea level. Mean sea level, you have maximum power available. But when your altitude will increase, suppose you got just imagine you got some 1 kilometer altitude, then your power available decreased. Then suppose you got some 5 kilometer altitude, then again power available decreased. And what about this guy? Power available. So you have maximum slope at mean sea level, but when you will go to some other altitude, suppose 1 kilometer, then you go to some other altitude, suppose 5 kilometer, so here you have power available, it is decreasing in this direction. Now we will combine our power available concept with power required concept, and the combined effect will give you idea of excess power, and excess power will help you to climb in the sky. And because of this concept we used to change our chapter from steady level flight to climbing flight. Copy down this. Okay, I will change the page. Now see, we will understand a new topic by combining these two diagrams, minimum and maximum. Yes, just a minute, I will read the complete chat. Minimum and maximum speed of an aeroplane. What is the chat? Yes. That's why in the beginning itself we decide, suppose you have to go to Chennai to Bangalore, distance is not much, then you don't use a jet engine. It will come soon, everything will be clear. You use propeller engine. Minimum and maximum speed of an aeroplane, how can we discuss? So if I am drawing power available versus velocity diagram like this and like this, so this I am saying power required and this I am saying power available. Clearly you can understand for which aeroplane I have done this diagram. Can you guess which engine? Piston engine. So another diagram, power available and velocity. So now I am drawing this diagram and power required is same, and you must cut this point. Okay, you must cut that point, and here also you must cut this point. You should not draw a smaller line, you should draw such that it should cut. Now you compare. Here you have maximum gap, maximum gap, maximum gap. Here you got the maximum gap. So the maximum gap is nothing but you have power available, you have power available and you have power required. Maximum gap is the gap which is telling you available excess power, how much power is extra. Suppose you are flying at this velocity. Suppose you are flying at this velocity. So at this velocity, if you will fly, then according to the envelope which is given on board, it will be mentioned that your power required will be this much and power available is this much. So it means you have this much excess power. You can use excess power. So how will you use excess power? There are so many ways to use this excess power. You can use for climbing. You can use excess power for running extra devices. Like there are so many things, because that is power. That power you can use for any purpose. Okay, but if you see the maximum gap in this second condition, only this much. So you can clearly see that this gap and this gap, power available is more. So in which condition power available is more? In propeller condition. And one more thing you check. The last velocity is here. So before this, if you will go, you don't have graph. So it means you will stall. So this is your stall velocity. And this is the maximum velocity what you can produce. After that, you cannot produce velocity. Why? Because your power requirement will be more than power available. So it means you don't have sufficient power. So your airplane cannot fly. So this is the maximum velocity. In same way, this is the maximum velocity here. Any aircraft can go. But here you have two interesting points. One, I'll use green color. One point is this and one point is this. So see, at this point, your power available and power required, both are same. It means this is the minimum velocity. And you will stall here. So this is your stall speed. So in case of jet engine, you got three important velocities: V stall, V minimum and V maximum. In case of propeller, you got V stall and V max. Copy down. So you got one idea that whether you talk about piston engine or you talk about jet engine, the maximum flight speed you can easily determine by the intersection point. Like the moment when power required and power level is same, that time that is your maximum speed. In same way, you can also talk about the low speed of aeroplane. How will you get? And stall speed, how will you get? Now we will discuss the combined effect. So in same way, under same diagram, we are going to discuss combined effect. Combined effect. Like as a pilot, you have to take both things in your mind, like how much power available is there, how much power requirement is there. So combined effect, if you want to check, then both the variations, power required and power available, both the variations we will draw on same graph. I will change the page. See, here you have power available and here you have velocity. So first I will draw a small diagram so that both can come. Under combined effect, you have to draw this. This is power available, this is power required, this is power available, this is power required. Now see, this is your power available, this is your power available, this is your power available, decreasing with altitude. And of course, when you will go to the altitude, density will be less, right? You need more power to go forward. So it means requirement is increasing. So your power requirement will increase like this. Okay, so this is your power required at mean sea level, but this is your power available at mean sea level. So this blue line is your power required at suppose some h1 altitude, or it's better you write more clearly. I'm writing more clearly here. Power requirement, suppose I'm writing at 5 kilometer. So this one I will write power available at 5 kilometer. Then the last one, the blue color, I will write as like power required as 10 kilometer. Then the black one, last black one, I will write as like this one, power available at 10 kilometer. So you can see, if you until your requirement can be completed by engine, you can fly. So same diagram, only two diagrams I will draw here. One I will draw like this, and for that altitude I should draw more slopey like this, like this. I will draw like this, and then I will draw another one, and for that I will draw like this. Okay, so this one I am drawing for suppose mean sea level, and this one I am drawing for 5 kilometer altitude. In same way, this one I am drawing for mean sea level, and the blue one I am drawing for 5 kilometer altitude. So this is giving you idea that when you are going on altitude, then your excess power is decreasing. So for that, in both the diagrams you can see, at mean sea level, if you want to discuss, so compare where is your mean sea level. So this line is your mean sea level and this line is your mean sea level. So both the lines, if you compare, you have this much excess power, right? So it means you have more excess power. But if you consider 5 kilometer, suppose this altitude 5 kilometer and this altitude 5 kilometer, so excess power decreased, right? And in same way here also you can check, this much excess power you have, but suddenly this much excess power. So mean sea level and 5 kilometer decreasing. So you got some observations. Those observations are like power available decreases with altitude increases, or you can say with increasing altitude. And just opposite, you can say power required is increases with height with altitude. And you can also say that third point, power which is excess, is also decreasing with increase in altitude. And fourth point you can take like this, your maximum available velocity is also decreasing. You can see it was here, this part, then it was here, this part. One mistake I had done. This is not required. This is not required. This is the velocity. And you can see this velocity is also decreasing. So velocity Vmax is decreasing. Vmax is decreasing here also, and you can see here you have Vmax and here you have Vmax. So again Vmax is decreasing with altitude. So Vmax is also decreasing with altitude is increasing. So I have a numerical, we can solve that numerical. But numericals are very easy in flight mechanics. If you can solve aircraft structures type of numerical, you can solve these numericals like easily, very easy. Only formula based numericals. So now we can talk about gliding and climbing. So in gliding and climbing, no, these are just variations. They don't have special names. It's not like drag polar or something. They are simply variations. Now we have to talk about gliding. In gliding, anything special is not there. What is special there? You may be confused with load factor. So in case of steady level flight, you should know what is load factor. So that is the last point about steady level flight. So change the page and just mention the last topic under this chapter. Load factor for steady and level flight is C. Load factor is always L by W, symbol is N, it is 1. Now we will discuss gliding flight. I will change the page. So take the heading as gliding flight. So it is not a steady flight. Why it is not steady? Because your altitude is being changed. Constantly you are losing the altitude. So what kind of diagram you should draw? One thing you keep in mind, your nose will be down. Suppose this is the aircraft. So nose will be down. So aircraft will go in this direction. So aircraft is going in this direction. It means what? Air will go in this direction. It means lift is perpendicular to the air. So suppose this is the center of mass. So I am talking lift is here. And no doubt drag is acting, weight is acting downward always. Okay. Question. Why aircraft is going downward? Answer. Because of the weight. Is it because of full weight? No. It is not because of full weight. Then how much weight? One component of weight is here and another component of weight is here. Okay. So if you will say that this is the angle, then that angle is nothing but this glide angle. So mostly we use capital gamma, but in GATE exam, they can use any symbol. They can use theta, x, anything. So you should not be bothering about symbol. Concept is lift is not able to balance the entire weight. It is only able to balance W cos capital gamma. Right? So that's why the flight is coming down. And because entire weight is not balanced. So definitely some component of weight will take the aircraft down. So that is W sin. So W sin gamma is the responsible factor which is acting in this direction. W sin gamma is acting in this direction to take the aircraft down. So just opposite to this, drag will be acting. We know that drag acts in the direction of free stream. So what kind of equation you are balancing here? You are balancing W cos gamma is equal to lift, because only this much portion is balanced by lift, and you are balancing W sin gamma is equal to drag. Imagine when you analyzed that you are gliding, that time you had this much altitude, suppose h, and when you are hitting the ground, yes, what no, anything. That's what I said. Anything we can use. Gamma, theta, alpha, beta, anything you can use, no problem. Only thing is you should know what is that angle is. You use this gamma. So if I use this gamma, then why will you not say this is adiabatic index? Right? It is just an angle. I mean, I am just taking this as a symbol. If you are not comfortable, replace with theta, no problem. But you should keep in mind it is glide angle. Now see. This height is h when you analyze that you are gliding, and so from this location you are going to hit this much distance. So this is going to be your range. So according to tan gamma, from the triangle you are getting h by r, and from this equation what are you getting? From this equation you are getting tan is nothing but, if you divide properly, like this equation divided by this equation, then you'll be getting tan gamma is d by L. So I can equate both the equations as equation 1 and as equation 2. That your h by r is equal to d by L. And from here you can know how much range you will cover when you are gliding from this much height and aircraft is producing this much lift and drag. Okay, so from this they ask theoretical question. They can ask theoretical question. You shuffle this equation and write as r is equal to L and h into L by d. If I shuffle like this, I can write. Now see, if I am behind that, r should be maximum. Suppose there is a situation, you are flying in the aircraft and there is some technical fault in the aircraft, and because of that it has to glide. Every aircraft having this gliding phenomena. Every aircraft is equipped with the gliding feature. Every aircraft, Airbus, Boeing, Cessna, everyone, they can glide. And right now I don't remember their gliding distances according to their heights, but it is available on Google, and it really, the distance is amazing. It is very, very big distance. So suppose you want to find out, suppose any accident happened and you want to suppose you want to land somewhere, but that landing location is not near. Landing location is not near, so it is far. It means what? You have to make your R max. So to make R max, in this you have to think which property should be maximum, which property should be minimum. So it is clearly seen that to achieve R max, your drag should be minimum. And if drag is minimum, then only this L by D will give you maximum value. So your R max is nothing but H into L by D. This is maximum. When this guy will be maximum, then only R will be maximum. It means what? This is minimum drag condition. Copy down. Now, you must mention on the next page. I am changing the page. You can mention anywhere. Sail planes are specially designed with this criteria. It means in the sail plane, because they are specially made for the sailing, so they should have the maximum range. So all the sail planes, have you seen sail planes? Very long wings. Okay. Now if something is coming down, then there is a technical word for that. That is called sinking. It means something is sinking. In Hindi you will say डूबना, कुछ डूब रहा है. So we have to bother about the sinking speed. Suppose if your sinking speed is very fast, then you will hit the ground very soon. So we should work on the such design so that sinking speed should be minimum, so that in dangerous and awkward situations pilot can have more time to decide, to take decision. I will change the page. Sinking speed is your next topic, and approach will be to achieve maximum time. Yes, because this is nothing but same word. I mean, it is just wording is changed. Just a minute. Only wording is being changed. Descent, glide, you are coming down. Okay, I was explaining to work on the sinking speed. So see, you are coming in this direction at a particular angle I have considered as capital gamma. This is V infinity. This V infinity will be having component. One component is in this direction and one component is in this direction. This component is taking the aircraft down, so you can say V sink. You say Vs. This component, with this component, aircraft is going in forward direction. So V forward. So if suppose any accident happened, anything happened, pilot needs more time to think. Anyway, whatever time is there, in that only pilot will think. But as a manufacturing company, you should design the wing, aircraft such a way that it will give you maximum speed while sinking, maximum time while sinking. Okay. So this Vs, you have to make as minimum as possible. So this Vs is nothing but the sine component of V infinity, right? Sine gamma component of V infinity, clear? So in this sine only you have all the important factors. Side by side, you know that your sinking speed is nothing but you are coming in this direction. So this height and how much time you want. Okay, or this height by time only you can calculate this. Okay, see now. This time we call as endurance. So this T you can replace with endurance and you can write H by Vs, and from here you can see your endurance is actually inversely proportional to the sinking speed. So if your sinking speed is minimum, then only endurance is maximum. So next line you can write E max is actually proportional to 1 by V sinking minimum. So how will you find out this minimum sinking speed? For this, you have two types of sinking cases. You can have very small angle of glide or descent, or you can have large angle of descent. In both the cases, we find sinking speed in different way. So actually 13-degree angle we consider as our reference angle to decide a small angle of glide and large angle of glide. So I will change the page. See. Okay, going back. Take down. The T is time. E is endurance. Replacing time with the new word endurance. Done? Okay, I will change the page now. Not here, here. See, you have to write. Actually, what we are going to do, we are going to find out sinking speed. So you write two cases for minimum sinking speed. See, authority has decided this. Case 1. Aviation authority, that if your gamma is less than or equal to 13 degree, then it will be I will give you two types of numericals to solve after this performance. One type of numericals are basic and conceptual numericals, and one type of numericals are special numericals. Those special numericals are not for GATE exam, but I want you to solve for like some kind of physical feel. So you might have heard about JATO, NATO, these kind of engine specifications. So using JATO, NATO, we improve our thrust augmentation and something, lot of things are there. So all like at university level questions are also very good questions. But in GATE exam, I will mention properly when I will be sending you PDF, what is for GATE, what is not for GATE. But for your interest, you can solve both. Okay. So see guys, your heading is two cases to find minimum sinking speed. Okay, in that your first case is for gamma less is equal to 13 degree, 13 degree. So this kind of angle is considered as a small angle of glide or descent. What is the spelling of descent? C and T or D? This. Okay, so this is correct. Okay. So now see here, if you bother about the diagram, you should draw like this. Like this is the horizontal line So you are gliding like very less, like you are not even gliding, like very less, like very long gliding. You will go like this, like this. So if you have horizontal surface here, then you can see this angle is very, very less, or this angle somewhere it will meet, right? Somewhere it will meet. So that angle very, very less. So that time you have hydrogen, sorry, you have h, that is height, and then you have this range r. So just now we have seen that our tan gamma was coming as d by l, that I can write as cd by cl. And if I am writing this as cd by cl, then I can also write this as by sin gamma by cos gamma. Now see, from here mathematics is being involved. Like we have lot of assumptions, right, in mathematics. So one assumption says, if your gamma is this much less, then of course you can consider that your cos became 1 and this sin will be alive there. So then you can write your sin gamma is actually cd by cl. Okay, since gamma tends to 0 we are considering, then we are writing this approach. Okay, it means cd and cl, this value, I mean whatever sin gamma I have found out, this value I can directly put in the Vs formula. If you remember, before few minutes we found Vs is nothing but V infinity sin gamma. So in this sin gamma I can replace my cd by cl. Okay, and after substituting there, V infinity itself I can convert in terms of weight and lift and something. So I'll be getting my final formula for Vs. So now see, I'll be getting a condition. I'll change the page. Copy down first. I'm considering my gamma is tends to 0. I can consider because it is done by authority, aviation authority. They have told us like, okay, if gamma is this much, then you can consider that gamma is very minimum. So in that case, cos gamma you can write as 1, because cos 0 is 1, so tends to 0. That concept will come. I will change the page. See, so your Vs will look like your V infinity. Okay, take it. Okay, Vs. Yes, you are asking this time. In the beginning itself I told you, right, we have two components. If you have no, here I am representing this Vs for, this is your V infinity, this is your V, I have given complete word, this is sink, and that's V sink I am writing as V stall or Vs. Don't be confused, this Vs is not stall Vs. Okay, now see. So because this Vs is equal to V sin gamma, and this I can write as this V infinity. This V infinity I can directly write as under root 2W by 2, rho SCL. How can I write this? You should not have confusion here. And CD by CL. So this became your formula for Vs. But this formula is giving you an idea under what condition you should fly aeroplane so that Vs should be minimum, so that endurance should be maximum. Okay, for that purpose we are doing all these things. To make Vs minimum, we are doing all these things. So you can clearly see your Vs is actually proportional to CD by CL power 3 by 2. Right? Which is the condition of minimum power. Sink velocity and descent velocity is different. Sink is this. This I am talking as sink. And if you are saying that aeroplane is going in this direction, you can consider like it will be mentioned. Free stream will come in this direction, correct? You are descending in this direction. So they will give you on this path you have velocity. This is sink velocity. So see, this is minimum power condition. Minimum power condition means I have given you some symbols, right? CL by CD should be maximum for minimum drag. CL by CD. So this is minimum power condition. It means what? Yes, Ranjit, ask without. No. Cos gamma. No. No. Actually, no. Actually, no. Actually, if you are saying your angle is small, that in that condition we consider this cos gamma is 1. That's all. Only the cos gamma we put 1, because for the cos itself we consider, okay, cos gamma is 1. Why? Because cos gamma will be giving you very close value. It's like if you see the cos graph, so for almost for 13 degree you will be having angle. Definitely it is less than 1, but it is okay to take 1. And if you will think in this way, like limit gamma tends to 0 sine gamma, if you will think in that way, then of course this sine gamma is going to be 0. Sine gamma will not give you as gamma. I mean, you are saying some wrong information, so that's what I'm correcting that. Sine gamma will never be equal to gamma. Okay. Now see. I will erase this part. So this is minimum power condition. It means if you want to make this part minimum, then this entire part should be minimum. It means opposite of this, 1 by CL power 3 by 2 by CD, this should be maximum. So this is your minimum power condition. So to make endurance maximum, Vs will be minimum for minimum power condition. But if your gamma is not less than 13, that time you will not reach to such kind of situation, like any kind of bold situation. That time you will be having a final mathematical answer. So that time you cannot consider anything 0 or anything 1. So I will just give you look for that. Copy down this. Yes, Akash, minimum power condition. I think very soon the time will come when I'll be teaching only 5-6 students in live class. Earlier students were saying that, sir, I want offline class. And now it is online class, that also they are not attending and they are comfortable with the video. Done? Okay. See, I'll change the page. Yes, Pratik? Minimum, na? Vs will be minimum. Vs Vs will be minimum. You check your previous notes. I have given endurance is actually proportional to Vs. So make endurance maximum. Vs should be minimum, and to achieve minimum Vs, you should fly at minimum power condition. And what is minimum power condition? Already we have discussed in previous classes. Okay. I'll change the page. Now see, case 2. In case 2, when your gamma is considered to be greater than 13 degree, that time you don't have any classical situation, because you are not going to keep anything 1 or 0. So direct you have the Vs value. So that Vs value comes as 2W by rho s into CD by CL square plus CD square whole power 3 by 4. No need to have proof, because anyway, even if you will prove, you have to mug up the last formula. So in the question, in GATE exam, if they are giving glide angle more than 13 degree, suppose they are giving 17 degree or 21 degree like that example, so you will use this formula. Now we have climbing, but in case of gliding, last topic about this load factor. What do you think about load factor? Option 1, less than 1. Option 2, equal to 1. Option 3, greater than 1. Option 4, 0. Load factor, guys. Two students less than 1, 2 students more than 1. Remaining students, what is your logic? Remaining students, take your answer. At least take a chance, take your answer. This is not GATE exam. You can do at least tick, right? Okay, now see. I will change the page. Just now you saw that your aircraft is going in this direction, lift is acting in this direction. For gliding, I am asking, lift is in this direction, but your weight was in this direction. Means what? This lift was not balancing the entire weight. Weight, what was balanced by the lift, it was only W cos gamma. It means what? Your lift was equal to W cos gamma, correct? What is load factor? Load factor is exact the ratio of lift by weight. So from this equation, if you are finding out lift by weight, so send the weight down. Lift by weight is equal to cos gamma. Cos is always less than 1. Cos gamma will always be less than 1 in case of gliding. So this load factor is always less than 1. Okay, so less than 1 is correct option. Now we go for climbing. I will change the page. So you go for climbing. So see, whenever we have climbing, same symbol I will use for climbing also, only the direction will change. Means earlier I was gliding like this, now I will climb like this. And I will put my aircraft here. Okay. So if aeroplane is gliding in this direction then free stream will come in this direction, then lift will be acting perpendicular to free stream, but your weight will act always downward, and from the horizontal I am climbing, this is the horizontal line, I am climbing at angle capital gamma. So I have component of weight like this. I hope all the students are not having any trouble in component now. If this angle is gamma, this angle will be gamma. So this will be W cos gamma, and this component, or you say this component, is going to be W sin gamma. Okay. Aircraft is climbing. So definitely aircraft is producing thrust. So thrust is acting in that direction. So definitely drag is also acting. So in backward direction you got two forces. One is drag and one is component of weight. That is W sin gamma. Clearly you can understand. Now thrust is balancing two people, drag also and W sin gamma also. So your first equation you got as your thrust is balancing drag also plus W sin gamma also. It means what? If the entire weight of aircraft is 1000 Newton, then out of this 1000 Newton, some Newton weight is balanced by the thrust. Okay. It means only some weight is remaining which is balanced by the lift. That is W cos gamma. So you have another equation, L is equal to W cos gamma. Okay. From this equation, you can again see your load factor is lift by weight, which is coming again as cos gamma, which is again less than 1. Right? Because cos gamma is less than 1. Cos gamma is less than 1 because gamma value is not going to be 0 or 90 degree. It will be in between. So value will be less than 1. Okay, clear. So you should not write less than 1. You should write like this. More than 0 and less than 1. Like this you should write load factor. Okay, load factor clear. Now you see this equation is very, very magical equation. In future, whenever you are revising climbing case, always focus on this equation. This equation gives you physical feel and all the mathematics involved in the climbing topic. So with the help of this equation, we have to like transform little bit. How to? I will change the page. Very important equation for climbing. I will change the page. See now. T is equal to D plus W sin gamma. From here, if I will try to find out gamma value, then gamma is nothing but T minus D by W and then sine inverse, right? Okay. You see here. This has lot of logic. If I am drawing my climbing diagram, suppose I started climbing from this location and I reached here, and I am saying this is my gamma value. So, and I was going in this direction with free stream velocity v infinity. Then this velocity will be having two components. One component will be in this direction and one component will be in upward direction. So this upward component I am drawing here. So this is taking the aircraft up. So this component I will say V ROC, rate of climb. Sometimes you can say only ROC. Sometimes you can say VC. These are the symbols for rate of climb. It means what is rate of climb? What happened, Pratik? Pratik, what happened? V infinity. This is, sorry, it is V infinity. It means aircraft is going in this direction, then free stream will come in this direction, right? So aircraft speed and free stream speed will be same. Okay. You know this from propulsion. Okay. Now see. What? I will explain what is that. I will explain what is that. Steady means you are climbing with very constant velocity. You are gliding with very constant velocity. See what Vedant is asking. Guys, I am telling everyone, whenever you are asking anything, you ask in public so that others can read that part. So I can save some time. So see now, from now onwards, everyone, whenever you are asking any doubt, ask in public. Because anyway, you are asking any doubt, that doubt everyone will see when they will revise the video lecture. And don't hesitate to ask anything in public. This is our class. See now here, when we are having this kind of climbing, then constantly your direction is same because angle is fixed, direction is same, and with same velocity you are climbing. So you can say steady climbing, but you cannot say steady and level climbing. This is totally nonsense. Okay, so steady climbing means your velocity is constant. Velocity means speed and direction both. In same way, you have steady gliding. Okay, you don't have concept of steady and level gliding. No. Clear? Okay, see now. We have ROC. What is ROC? ROC is the vertical component of the free stream, so it is going to be V infinity sine gamma. So your ROC, or you say your VC, is nothing but V infinity sine gamma, because only it is symmetrical, that's all, very similar to that. And sine gamma you can find out from this equation. So your VC you can write as V infinity, send sign here, so sine gamma will be T minus T by W, T minus D by W. Okay. If you want to climb faster, now see again that kind of concept is coming. In gliding, we wanted to sink as slow as possible. Suppose in climbing, you want to go faster. Then your rate of climb should be maximum. How will you maximize rate of climb? To maximize rate of climb, you analyze this equation. In this equation, you have, if you want to maximize this term, this drag should be minimum. So here you got one physical behavior, minimum drag phenomena. Okay. So minimum drag means what? Minimum drag means parasite and induced, they both should be equal. So from here you got one logic. Maximum ROC means minimum drag, point 1. Second point, maximum angle of climb, AOC. You write the full form. Maximum angle of climb is equal to, you can see here, gamma should be maximum. Gamma will be maximum if and only if your drag is minimum. Again the same concept. Means minimum drag. Whenever you have minimum drag condition, you should know that your parasite drag will be equal to your induced drag. Keep in mind. And if possible, these small informations, while revising, you should write everywhere. Now see, angle of climb, AOC means angle of climb. Okay. Now, when you talk about maximum rate of climb, then for jet engine, maximum rate of climb we approach in different way. For jet engine. So, in case of jet engine, we have to discuss maximum rate of climb, and just now you saw that here we got minimum drag condition to achieve. No, I have done mistake here, 1 minute. Actually, this expression contains thrust also and weight also. So we cannot target maximum rate of climb under minimum drag condition. So you delete this part. Only maximum angle of attack, maximum angle of climb is correct for minimum drag condition. My first statement was wrong. Okay. I have one proof here. So that proof says, just a minute, just copy this. First you erase this. I will change the page. I will explain properly. When we talk about climbing, I will explain why it is not valid for ROC, but it is valid for angle. I will change the page. Now take down. Now you understand why it is wrong. Because see, very soon you will realize that your maximum climbing, ROC is the engine phenomena. Because you have to produce the engine. Thrust and power you have to produce from the engine. Just now you have seen this situation. Means this is the excess power. By using this you will climb. But when you are climbing, your excess power itself is decreasing. So every time you will not be having same rate of climb. Okay? Because your power is not constant every time. That's why we should focus on some more factors. We cannot focus only on drag. But angle is geometrical phenomena. It is simply as an angle. It is just angle. So angle will be maximum. No problem. Angle can be maximum. And one thing is very clear. If you want to fly at this angle or at this angle or at this angle, it depends what kind of aircraft you are flying. So angle will not disturb you when you talk about drag. But because both the engines, jet engine and propeller engine, they both have issues with available power excess power according to the gap between available and required, like this gap and this gap. So this gap and this gap. So we will discuss our climbing according to the gaps for both the engines. So your next topic is maximum rate of climb for jet engine. So if you are having jet engine, then first of all we have to consider gamma is less. It means wherever you will be having cos gamma, approximately it will be value 1. So only for this condition we will discuss maximum ROC for jet engine. Because for fighters we don't have this concept. Of course we have, but we don't have to study for the fighters, because fighters can have ROC at any angle. So what do we do? First we write the equation of V climb, and then that will be in form of V infinity and sine, and then we substitute the values. We keep on substituting. Then we have to differentiate with respect to a big factor, and after that we receive a result. So proof is not important, and result you have to mug up. That result is BCL square plus TWCL minus 3CA is equal to 0. This ABCL, they are from the drag polar. When this total is equal to 0, then we consider your jet engine will fly at maximum ROC. Means they will give you a particular thrust, weight will be mentioned, and A and B will be mentioned. And you have to find out the CL at which a jet engine will get maximum ROC. So from here you will find out the CL by using this equation. So condition for maximum rate of climb for jet engine, but not for propeller engine. Yes, it is quadratic. So if it is quadratic, then you have two values of Cl. So for that I have a numerical. That numerical I will give you. You can solve for the two values of for both the values of Cl, and you can choose for which value of Cl you are getting maximum rate of climb. Because you got two values of Cl, right? So it is your choice to check. So for both the values of Cl, we can find ROC and choose the maximum ROC. Maximum ROC for maximum ROC for related Cl. Like I have an example. In that example, two values of Cl is coming. One is positive, one is negative. So on both the values of Cl, I will find out my CD value, and I will put in the equation. I will find out my Vmax value. So Vmax value will be something. Now we will discuss important part. Based on this, they have asked this question many times. Piston engine aeroplane. Copy down. Done. Okay, I'll change the page. See, now you have to take the topic case 2. In that case 2, you have ROC for piston engine. So in this case, we start with direct equation. We know our VC. This was nothing but V infinity sine gamma, and sine gamma was nothing but T minus D by W, right? So here, because we are discussing about piston engine, and we know piston engine works for power. So what do we do? If I will multiply this inside here and here, so you remember force into velocity gives you power. So both will convert into power. So this VC, when you multiply this with this T, this T becomes T available, because you know in case of jet engine, T available is constant, right? So when you multiply this V infinity with this T, so you will say that this is power available. And when you multiply this V infinity is D, D means what? D gives you the required amount, whatever is required, the drag. According to drag only, we discuss our power and thrust and power. So this is your power required. Divide by weight. So from here you got the logic. Your VC will be maximum when power required will be minimum. Or you can say VC will be maximum when, you can see the gap here, power available and power required, that is gap. That gap is excess power. When excess power is maximum. Now we have great logic. Great logic. Now you can easily guess the idea why we use propeller engine at lower altitudes. It is very clear now. So why do we use propeller engine for the lower altitude? Because you can see your ROC will be maximum when your excess power is maximum. And excess power, just now we saw excess power was maximum according to the graph you check, right? This is for propeller and this is for jet engine. So excess power is maximum for propeller, not for jet engine. That's why we use propeller engine for the lower altitudes. Because of ROC is the problem. It means what? Rate of climb. It means propeller engines will gain the altitude quickly. Yeah, any propeller engine, turboprop is a propeller engine, right? But when you have to travel a long distance, then you have to fly high also, and you need more ROC also. That's why we compromise and we go for turbofan engine. Anyway, that portion is different discussion. Okay. But see, what if they are giving you a condition where they are also mentioning the efficiency of the propeller engine? So for that, I will change the page. Rate of climb of piston engine when efficiency of propeller engine is given. So you just use efficiency of propeller engine times P available minus PR by W is equal to V sin theta. This V sin theta is not. Done. Now we will take the topic absolute ceiling and service ceiling. Still we are doing flight where we are not considering acceleration. I'll change the page. Now take down another topic, absolute and service ceiling. So see, what is absolute ceiling? Absolute ceiling is the altitude at which maximum rate of climb is 0. It means altitude at which maximum rate of climb max is 0 is known as absolute ceiling. It means what? Your ROC is 0. ROC 0 means that gap is not available. That was available between power and available and required, right? That is not available. So you can see here, if you're talking about propeller engine, then your required will be like this, and if you're talking about jet engine, then your required will be like this. So in both the cases, your power available is equal to power required now. So you don't have extra power to climb. So it's correspond to the altitude for which the power available and power required is same. Done. Now, actually, if aeroplane will fly at this altitude, and imagine there is sudden disturbance. Suppose any gust is coming, for example, horizontal gust is coming. Then what will happen? Then suddenly aeroplane will go out of control, because power required will be more than power available. How? Now see. These things are the part of aerodynamics, Vedant. That is nothing anyway. If you are talking about, just a minute, I'll see the chat. See, gust load and interference load is very easy. Gust load is like, right now we have 4 loads. Any extra gust will come, then we'll be having extra loads on the wing, on the fuselage. That load is because of the air. And interference drag is different. Interference drag means when you combine 2 components, that time you achieve the drag. That part I will teach you in aerodynamics. Now see. You got 1, 2, and actually I think you are not reading the PDF, right? For this only I have given the PDF so that small topics you can read. Everyone start reading all the PDFs. In the PDFs I have given all small topics. There are so many small topics what I have not covered in live class, because it's like they are the basics. I mean, they are really very small basics. So if I will take all those basics in live class, then it will take 4 to 5 extra classes. And you'll be bored also, like they are small topics. Okay, anyway. So altitude at which ROC max is 0 means rate of climb is 0. Rate of climb means 0 meter per second speed you will be having to go up. And if you cannot go up, then what will happen? You should never touch absolute ceiling. So if you should never touch absolute ceiling, then how much you should touch? You should touch a particular speed that is decided for both. Now we'll go for service ceiling. Service ceiling is what? It is a specified value. It is a specified value. And authority has specified this value. And that value, your ROC will be 0.5 meter per second for piston engine, piston engine aircraft, and your ROC will be service ceiling 2.5 meter per second for jet engine aircraft. It means what? You should go only till that altitude where you can maintain only this much rate of climb. You should not cross that altitude. And especially it is for commercial aircraft. Of course, fighters can do anything. So this is actually a specified altitude. So service ceiling means because you have to give service. So how much ceiling you should attain? service ceiling. So only this much height is allowed, where you are achieving this much meter per second, this much meter per second. Do you think after that you cannot climb? You can climb. No doubt in this. You can climb. But that will not be safe for commercial aircrafts. Now if I will ask, do you think your weight will affect absolute ceiling and service ceiling, anything? ROC max. Do you guys think? I don't know in feet. You just convert in feet. This is in meter per second. Okay. Now see guys, we have to bother about the variation of weight. Like if you have heavier aircraft, then it will service ceiling and those things. So actually your rate of climb is all about minimum power. Mostly we are talking about this plane. I will change the page. Here you have to write effect of, actually these questions they ask, effect of weight on absolute and service ceiling. So you know that ROC max is nothing but power available minus power required but minimum divided by weight. So you see here, higher the weight is smaller, you can see directly. Higher the weight is smaller will be the rate of climb. So lesser will be the absolute ceiling. It means if I will draw using curve, so your height and ROC curve will go like this. And I will draw two different diagrams. This is for W1 weight, this is for W2 weight. And I am considering W2 is more than W1. And this is your altitude versus ROC max. So somewhere here you should cut and you should say that if it is propeller then it is 0.5 meter per second, or if it is jet engine then 2.5 meter per second. Like this much ROC you should touch. It means what? Only this much height is permissible. This height is not, you should not touch at particular weight. And if you are flying on the W2, then you should not touch this much height. Copy on this. Now see, we are remaining with the last topic in steady performance, that is range and endurance. That is very easy. Like whatever technical part was available, that was here, whatever we have discussed. Now last topic is range endurance. That is not a technical topic. It is very easy topic. In that you have to know types of phases. Like we have types of phases in the flight. Like for example, takeoff, climb, cruise, glide, landing. That's all. And a little bit in landing, like we have flare and then we have approach and then we have landing. So that's all is remaining, and we will in that nothing, concept is not complex, very simple. So for landing and for range and endurance, I will give you the formula. Venn diagram will not discuss now. In case of load factor is clear now. Okay. All the three load factors is done. Okay, I will change the page. Now, in case of range and endurance, you have some theory. What is the theory? When you talk about types of range, then you have like safe air range, you have still air range, gross still air range, like those things. So quickly I will give you the idea about the range. What is safe air range? Suppose this is the entire flight. You started from here, you landed here. Then you are doing takeoff, then you are doing climbing, and then you are cruising, and then you are gliding, and then you are coming back, landing. So this became your safe air range. I will send you photos, so don't worry about making notes. And if you remove gliding and this part, landing part, then whatever is remaining, like takeoff, climb and cruise, that is known as still air range. It means only this part, then this part, and then this part. This is known as still air range. And if you are talking about gross air range, then you remove this two also. It means only this, I mean here, only this is your gross still air range. That's all. And then we have calculation. So we have the way how to calculate range and endurance formulas. So that Breguet equation, no need to prove everything. So I have taken all the 4 formulas, important formulas, and those formulas I will give you. So range endurance formulas are important, and theory I will give you so that it will be with you always whenever you are forgetting these kind of ranges and everything. Who knows, this time they will ask one numerical theoretical question based on range itself. Which one is still air, which one is safe air, which one is gross air. So for that I will send you the PDF. I'll change the page. See now, take down the formula. Range and endurance for propeller. Now here one important point I want to say. We have 2 types of aircraft, propeller and jet. So for both we have 2 formula for range endurance and 2 formula for range endurance. So first I will give you formula for propeller. So propeller, in that I will give you range formula. See, you may be knowing in UPSC exam, first you write pre-exam. So my formula, why I am giving, it is a trick actually. Propeller, range, endurance. I am giving you in this way. So in same way I will give you endurance formula. Take down R is equal to eta P by Cp, and you exactly write in my way. It will be easy to remember. Cl by Cd into ln of W1 by W2. What is what I will give you in the last. But just copy down now. And then endurance formula. Eta P by Cp under root 2 rho S into Cl power 3 by 2 by Cd 1 by under root W2 minus 1 by under root W1. Take care properly. Then you take range and endurance formula for jet engine. In same pattern. First take for range. Now 1 by Ct. Cl power 1 by 2 Cd under root W1 minus W2, and one more part I have to write here in the I forgot, 8 by rho s in the under root. Don't miss this part, 8 by rho s. And then you have endurance formula, CT, that is CT, thrust specific fuel consumption. I will give you the details properly. First take down 1 by Ct, Cl by Cd, ln of W1 by W2. You can clearly see CL by CD ln W1 by W2, CL by CD ln, they are same, right? So first formula and last formula is same, only here you have eta P by Cp, here you have 1 by Ct. Okay. Under root 8 by rho s. Under root 8 by rho s. This is nothing but under root 8 by rho s. Okay. So now you understand the variables. W1 is the first weight, W2 is the weight after some time, or you can say the final weight, right? You have to understand few more. CLCD you understand, rho and S you understand. Only you have to know what is eta P, what is CT, what is Cp, right? I will change the page for the variables, or it's better I can write here itself. I will change the color. Your eta P is propeller efficiency. Done. What is your Cp? Power specific fuel consumption. Power specific fuel consumption. What is Ct? Thrust specific fuel consumption. In short, you say PS of C, TS of C. Now, by using these formulas, what kind of theoretical question you can crack easily? For example, if I am asking, any aeroplane wants to fly propeller aircraft so that it should achieve maximum range. So in what condition it should fly? So for that you should check these values. CL by CD, CL power 3 by 2 by CD, CL power 1 by 2 by CD, CL by CD. These values you should keep in mind. These values are like, what is CL by CD? When CL by CD is maximum, this is minimum drag condition. I have given in the beginning days, right? And when CL power 3 by 2 by CD means minimum power condition. And this is minimum drag condition. So this kind of question they can ask. Like I can ask you, aeroplane is flying at maximum endurance, to achieve maximum endurance. Then under which condition it is flying? Minimum power, minimum drag, minimum dV. So you check this thing. This thing is maximum, then only it will be maximum. So minimum power condition. I can ask, for example, I can ask this. So in that way we have to reply. Copy down. So many numericals are there. So many numericals. I will send you all the numericals. You don't have to solve all the numericals. I mean, they all are examples. Only 4 or 5 examples you solve, and you'll be getting enough idea, because this entire syllabus is very easy. The flight mechanics. Now, the last part is takeoff or liftoff and landing distances. In that they ask only 2 types of problem. Yeah, I will send everything. I will send everything. And after sending, I will tell you, like for GATE how much you should study. But theory, everything, whatever theory I am sending, every theory you should study for flight mechanics. Okay, so now we are starting fresh unit, that is accelerated flight. In accelerated flight, we have total 5 types of flight. Okay, I will change the page. Chapter over. Now new chapter is being start. Accelerated flight. Actually, I took lot of time in propulsion, performance. Performance is not this much lengthy what I have taken. Performance is very small, because when you will revise, then you will realize that okay, only the formulas are there, nothing else. Of course, the idea of flap and errors and altitudes, they are important logics. Atmosphere, they are important. So that's why we took time in performance. Major part is stability. In stability, we have to pay attention more. In performance, no need to pay this much attention because it is not tough. It will not ask you to pay attention. So our new chapter is accelerated flight. In this flight, our first job is takeoff performance. So in takeoff, you should understand the phases involved in takeoff. So whenever you are taking off, first what will happen? First you will do ground rolling. Then like you will cover certain distance in ground roll from here to here. And after that you will be having air roll. Air roll. Or you can say air run also. When pilot will release the brake, right? That time ground roll will start. Ground roll means you are walking on the ground. I mean like vehicles. And then you have air roll. And after that, when you will, how much air roll you will do? You will be having some this much. Okay, this much is your air roll. It is not straight line. It is curve line. Okay, it is curve line. So you got air roll. After air roll, you will reach to a particular altitude. From that altitude, you will start your climbing. Okay, so this is not our part to discuss. We have to discuss this length and this length. So this total length you can say as your takeoff distance. So this total takeoff distance we have to study. So in case of takeoff distance, you only have to take one formula. That formula is S. Takeoff also you can say lift off also. Okay, don't worry, lift off. So symbol you can say S, or you can say takeoff, or you can say lift off. These are the symbols, LOLO. And formula is that formula 1.44 W square by rho infinity. And I have arranged in this way. GST CL max. Now see, there is a trick. I have arranged the formula to remember. Trick is in Hindi, rho means rona. Rona means cry. So rho. Why should you cry? Because your GST is maximum. CL max. GST is a kind of tax. Now here you should understand the same formula. Either they are asking by giving all the variables, then directly you substitute the value and you tick here. But they will not ask in that way. They will ask you the variations. Variations means in summer days, in hotter days, in winter days, your takeoff distance is increasing or decreasing. I mean theory which is directly depends on the density. Or they can ask if your wing loading is high, if your span loading is high, if your thrust to weight ratio is high. In that case, what will be your takeoff distance? So the same formula we have to arrange for all the important terms. Okay, so I will change the page. I will arrange the formula. Same formula. So your S you can write like this: 1.44 W by S divided by rho G T by W into CL max. Okay, you can see this W by S is nothing but your wing loading. T by S is nothing but thrust loading. And if in case they are giving W by B, then W by B is your span loading. Span loading. Okay. Now, by using these three words, if they are asking numerical, theory, you can relate here. If thrust loading will increase, distance will decrease. If wing loading will increase, distance will increase. Because directly proportional, inversely proportional concept will come. Okay. But if they are asking what is the relation between this and density, density is actually this density is free stream density. Keep in mind. So if they are asking density, so actually thrust also contains density term. And already one density is here. That's why your distance is proportional to 1 by free stream density square. So based on this, very clearly they have asked 1 or 2 times question. In summer days, runway will be shorter or smaller. If you are making runway in Jammu Kashmir, it will be shorter or smaller. If you are making runway in Chennai, shorter or smaller. It depends on the temperature, and temperature will affect the density directly. Okay. So at high altitude, at low altitude, density will vary. Some cities are there at high altitude. For example, Bangalore is almost 900 meter away from the mean sea level. It is even at more height than Dehradun. Okay. So that's why Bangalore is almost around 2 degree cooler than average cities. So in that case, how will you tackle this? So see, you should know that, just mention one point here, strong point. Summer or hot days will decrease the density. So needs longer runway. Longer runway. See here, if density will decrease, S will increase. So you need longer runway. So means you need longer takeoff or lift-off distance. They are not asking questions based on landing distance. So properly you have to focus only on takeoff or lift-off distance. But formula and all, we should mug up for both. So everything is similar. Yes. Ask. Because one row you can see directly here in the formula, and one row thrust is also here, right? Thrust. So in thrust formula also row comes. Because of that, we have 2 rows there. So that's why square. Correct? Actually, if you are installing high devices, then you are not comparing the same aircraft. So if you will compare the same aircraft in 2 different weather conditions, then this idea works. What if you are saying that you are installing high lift devices. So if you are it means you are changing the flight itself now. So that time you cannot compare. If you want to compare, you should use same aeroplane in summer also and in winter also. Then you can compare. One more thing, why are you replacing with that thing? It's better you replace with in takeoff only I'm talking. This is about takeoff. This is takeoff distance, or you say lift off distance. I am saying if you want to compare distances, then you should have same aircraft in winter also and in summer also. If you change the aircraft, or if you change the features of aircraft, then of course you are using different aircraft, so distances will be different. I mean to say, same aircraft, if it will fly in summer days and winter days, it needs longer runway here in this condition. Okay, so we have landing distance. Just a minute, only formula is important. Landing questions they are not asking at all. It's been so many years, not any single times. So we will not focus on landing at all. But just to be safe side, we have to mug up the formula for the landing. Okay, I will change the page. Take down landing distance. Landing distance. In landing distance, you have to write like this. From where to where? From V touchdown to V is equal to 0. Or you can also say, this distance you can also say as braking distance. means when the aircraft is touching the ground, and after that it is stopping from there to there. So S, that time S will be equal to V square touchdown, like at what speed you are touching, divide by 2A average. What is this? This is nothing but, if you remember, V square is equal to U square plus 2AS speed, velocity equation, right? So your because you are stopping, applying the brake, so put minus sign, and final speed is 0. Here you can see, and initial speed is touchdown speed. So this is the equation helping you to achieve this equation. That's all. And the same equation you can write in terms of the weight average, because acceleration will also change, right? We use parachute, we use friction, we use braking, everything we use. So at your retardation is also not constant. So that's why we have chosen average kind of acceleration. I hope you understand. Like you can see when fighters are landing on the carriers, right? We use all kinds of situations. Yeah. Okay. See now all the possibilities to now same equation, same formula, but in terms of weight of the aircraft and rho and all everything. So you see S is equal to 1.15 whole square, then weight square, divide by rho GS. After that, here you have to put big term, D plus mu W minus L, bracket close, and then you have to put CL max. This much big formula. That's why you don't have to focus on landing distance in the exam hall. What is mu here? Can someone guess? Yes, very good. So see guys, until your aircraft is rolling on the ground, you will be using dynamic friction. Just one more minute. Anyway, today's class over, but just one more minute. See, you have three types of friction coefficient: static, dynamic, and limiting. So in this case, we have to discuss dynamic friction coefficient. So this mu you just mention anywhere. Just to be safe side, I am giving this. Otherwise, it is just making the syllabus lengthy. Otherwise, so you just take down everything you recognize. Only mu you write. Dynamic. Oh, I myself forgot the name. What is mu? Coefficient. Yes. So you write dynamic coefficient of friction. Dynamic coefficient of friction. And in next class, we will start pull up, pull down, and coordinate turn. And because pull up, pull down, coordinate turn is very easy. Very easy. Only three formulas you have. Only three formulas. That's all in pull up, pull down, and this thing. So when I will teach you coordinate turn, that time I will teach you side slip. Actually, side slip basically we have to discuss in stability. In stability we have to discuss. Okay. So now we are ready to start stability, but I have very hectic work. I have to send you all the examples and theories. So I will sit after the class and I will take around 1 hour. And after 1 hour, I will send you all the photos. And theory part you have to study. Numerical part, no need to solve all the numericals. Solve easy numericals because they ask only easy numericals. Okay. There is only one part what I am saying you to ignore. I will tell you which part I am saying you to ignore in this. Only one time they have asked. Actually, you will be having two different weights, W1 and W2. And there is one question they have asked. You are gliding. So at different altitude H1 and H2, you will be at different timing T1 and T2. This is very faltu, like it is totally worst. No need to, it is not worth to study. That's why this part, no need to study. Like the equation in terms of time and all, no need to study. One time they have asked, only when you will solve that previous year numericals, that time you will find that there will be one equation. You can skip that. because there was one time when calculator was allowed, and if calculator is allowed, then they can ask any type of question. So smartly you understand, when calculator is not allowed, then they cannot frame equation on this kind of big equations. Okay, like for example, okay, that's all done. So today's class over.